Hello and welcome to Algebra 1 Lesson 18. In this video we're going to learn about parallel and perpendicular lines. So parallel lines are any two lines on a plane that will never intersect. We can determine if two lines are parallel by examining the slope of each. So non-vertical parallel lines have slopes that are equal. Let me highlight that. Non-vertical parallel lines have slopes that are equal. Okay, very important that you write that down. Now, vertical lines, remember, they have slopes that are undefined. So that's why we specify and say that non-vertical parallel lines have slopes that are equal, but vertical lines have slopes that are undefined. Now, when you first start looking at parallel lines, what you're going to notice is that there are lines that kind of look the same. So parallel lines look like this. Let's say I had a line that goes this way and another line that looked like that. So I know these aren't perfect, but you can see by looking at these lines that they're never going to intersect. And if we're on a coordinate plane, you'd also see that they have different y-intercepts. So essentially, you're looking for same slope, different y-intercepts. Those are going to be parallel lines. So then the other thing we want to talk about are perpendicular lines. And perpendicular lines are lines that intersect at a 90-degree angle. Okay, they intersect at a 90-degree angle. So two non-vertical perpendicular lines have slopes whose product is -1. So specifically, if I take two non-vertical perpendicular lines and I grab their slopes, I multiply them together, the result is always going to be -1. So we're going to look at a few examples here. Not really a difficult concept whatsoever. So we want to determine if each pair of lines are parallel, perpendicular, or neither. Okay, so let's start out with x plus 2y equals 4, and then 3x plus 6y equals 48. So when you get problems like this for your homework or for a test, the first thing you want to do is find the slope of each line. Now, we found out in the last lesson that an easy way to do that was to put your line in what's called slope-intercept form. And basically that means you're going to put your line in the format of y is equal to m the slope times x plus b the y-intercept. Right? This is the slope and this is the y-intercept. Okay? That's why it's called slope-intercept form. So essentially what you have to do is just take each equation and solve it for y. That's all you need to do. So I'll start out with this x plus 2y is equal to 4, and I'm going to solve this for y. So in order to do that, I'm going to subtract x away from each side of the equation. So that's going to go away from over here. And then on the left, I'm just left with 2y, and this is equal to, I now have negative x on the right, and then plus 4. I want y by itself, and what's stopping me is I have this 2 that's multiplying y. So I need to divide by 2 on this side of the equation, and to make it legal, I need to do it to this side of the equation as well. But remember, we're allowed to break this up and divide each by 2. All right, so then this would cancel with this, leaving me with just y over here. Over here, I have negative x over 2. Remember, I can always put a 1 here and say that's -1 times x, right? It's kind of an invisible coefficient. If you just have a negative out in front or nothing out in front, you could say, hey, if this is a negative out in front, it's really -1. If there's nothing out in front, it's just a 1, right? So I can think of this as -1/2 times x plus 4 over 2 is just 2. So there is my first equation in slope-intercept form. So what we can tell is that our slope, which we denote as m, is going to be -1/2. And our y-intercept occurs at the point 0, 2. Okay, let's erase everything and go back up to the top. I'm just going to keep this information right here. So for this first one, again, in slope-intercept form, we end up with y equals -1/2 x plus 2. And again, we said that this corresponds to a slope, which is m, equal to negative 1/2, and a y-intercept, that occurs at the point 0, 2. All right, let's take a look at this equation now. And again, all we're going to do is solve it for y. So we have 3x plus 6y equals 48. Okay, so if I want y by itself, I've got to first isolate the term 6y. So I would subtract 3x away from both sides of the equation. And this is going to cancel. On the left, now I just have 6y. And this is equal to negative 3x plus 48. In order to get y by itself, I need to divide both sides of the equation by 6, which is the coefficient of y. So I'm going to divide this by 6 and also this by 6. All right, so this is going to cancel with this. And negative 3 over 6 is the same thing as negative 1/2. So I'll cancel this with this. I'll put a 1 here and a 2 here. And then 48 divided by 6, we know that's going to be 8. So I'll kind of cancel this with this and just put an 8 and a 1. So we're going to rewrite this as y equals negative 1/2 x plus 8. What you can immediately see is that the slope, again, which is m, is the same as in the other equation. It's negative 1/2. The y-intercept, however, is different. So the y-intercept is going to occur at 0, 8. So this is your y-intercept. It occurs at 0, 8, right? That point on the graph. Okay, so let's erase this and go back up. Okay, so for this line, again, in slope-intercept form, it's y equals negative 1/2 x plus 8. Okay, and again, m in this situation is also negative 1/2. And then the y-intercept, let me kind of erase that real quick, is going to occur at 0, 8. So what we can immediately tell is that we have the same slope in each case, right? M equals negative 1/2, m equals negative 1/2. So same slope, different y-intercepts. We know that we have parallel lines. So these lines are parallel. So one thing I want to show you really quickly is what this visually looks like using a coordinate plane. So remember, we had y equals negative 1/2 x plus 2, and we had y equals negative 1/2 x plus 8. In slope-intercept form, these are our two lines. Now, if we know a point on the line and the slope, we can easily graph, right? Remember, we've kind of transcended the point where we have to go through and make ordered pairs and do all this stuff. We can graph really quickly now. So I know for this first one, the y-intercept occurs at 0, 2. So on the coordinate plane, that's going to be right here. And then my slope is negative 1/2. So remember, it's rise over run. It's rise over run. So this equals negative 1 over 2, or you could put 1 over negative 2. Doesn't really matter how you kind of think about that. So if my rise is negative 1, that means I fall 1. And if my run is 2, positive 2, that means I go over to the right 2. So 1, 2. So there's my next point. Down 1 over 1, 2. There's my next point. Down 1 over 1, 2. There's my next point. Down 1 over 1, 2. There's my next point. Or like I said, I could have also done 1 over negative 2. So if I started here, I would rise 1. And if I have negative 2 in the denominator, that means I go to the left 2. So I go 1, 2 to the left, up 1 to the left, 1, 2. And obviously, you don't need all these points to make a line, but I like to kind of do that when we're in our first stages, just to kind of get our brain used to graphing a line this way. Okay. All right, for the next one here, we have y equals negative 1/2 x plus 8. And again, we know a point on this line. It's at 0, 8. So that's going to be right here. And then to graph it, again, we just use that slope, negative 1/2. So I can fall 1 and go to the right 2. Fall 1, go to the right 2. Fall 1, go to the right 2. Fall 1, go to the right 2. And I'll go ahead and stop there. Or another thing I could do, again, I could use this. I could go up 1 and to the left 2. So let's go ahead and graph this. Some arrows in. And let me kind of erase this part real quick. All right, so it's not perfect, and no graph that you ever freehand draw will be. I mean, some of them are pretty good, but if you were to put these equations in on, a computer graphing program, you could really see. But even just looking at this simple hand drawing here, you can tell that these lines pretty much look the same, right? They have the same steepness or the same slope. What's really different about them is that they are on different parts of your coordinate plane, right? They have different y-intercepts. This one has a y-intercept that's at 0, 2. This one has a y-intercept that's at 0, 8. But if you were to extend these lines out indefinitely in each direction, because they're parallel to each other, they will never, ever, ever touch. Okay, so that's what we're trying to get across here. So again, two non-vertical parallel lines will look like this. They have the same slope, but different y-intercepts. All right, let's take a look at another one. We have 4x minus 3y equals negative 12. And we have 6x plus 8y equals negative 16. Okay, so again, I'm going to solve each for y. And I'm going to do this a little quicker this time. So we'll move this over here and say, okay, I have 4x minus 3y equals negative 12. Subtract 4x away from each side of the equation. So that's gone. I'd have a negative 3y is equal to negative 4x minus 12. All right, so the next thing I want to do is divide both sides of the equation by negative 3, the coefficient of y. So that is going to cancel with that, and I'll have y by itself. And this is equal to negative 4 over negative 3 is just 4 over 3, or 4/3, right? The negatives would cancel, times x, and then the negatives would cancel again, so plus 12 over 3 is 4. So I know for this one that the slope, which is m, is equal to 4/3, and that the y-intercept, is going to occur at 0, 4. All right, for the next one, again, I'm trying to solve this for y. So 6x plus 8y equals negative 16. I'm going to subtract 6x away from each side of the equation. So this is going to cancel, and I'm going to have 8y is equal to negative 6x minus 16. Divide each side by 8. So I'm going to cancel this 8 with this 8. And I'm going to have y is equal to, so 6 divided by 2 would be 3. 8 divided by 2 would be 4. So this would be negative 3/4 times x. And then minus 16 over 8 is 2. So my slope here is negative 3/4. My y-intercept occurs at 0, negative 2. So m is equal to negative 3/4. And again, y-intercept is at 0, negative 2. So kind of the first question you're going to ask yourself here is, are these lines parallel? Well, you see that the slopes are clearly different numbers, right? This is 4/3. This is negative 3/4. If they're different values, you don't have parallel lines. Now, the next thing you would ask yourself is, are these lines perpendicular? Well, perpendicular lines have a property that tells us that the product of the slopes would be negative 1. So in other words, if I took 4/3, which is the slope for this equation here, and I multiplied it by negative 3/4, which is the slope for this equation here, I should get negative 1 if these two lines are perpendicular. So you can see that you would, right? Because this 4 would cancel with this 4. 4 over 4 is 1. This 3 would cancel with this 3. 3 over 3 is 1. But I'm left with this negative here, right? So I'd end up with 1 times negative 1, or just really everything canceling except for a negative 1. And that would be my solution here, right? The product of the two slopes would in fact be negative 1. So we do have perpendicular lines. And again, to kind of look at this on a coordinate plane, let's take a look at our two equations in slope-intercept form. Again, we had y was equal to negative 3/4 x minus 2. And we also had y was equal to 4/3 x plus 4. So again, really, really easy to graph these. We know the slope and we know the y-intercept. So we have a point on the line and the slope. So for the first one, the y-intercept is going to occur at 0, -2. So that's right there. My slope is -3/4. So again, with rise over run of -3/4, or again, you can think about this as 3 over -4, doesn't matter. In the first scenario, I would fall 3. I would fall 1, 2, 3, and I would run to the right 1, 2, 3, 4. And I can make another point, but that's going to kind of go too far. So let me kind of backtrack over here, and let me use this now. Let me rise 3, 1, 2, 3. Let me go to the left 4, 1, 2, 3, 4. So that's another point. And let me graph this real quick. Okay, and now for the next one, let me just erase this. We have y equals 4/3 x plus 4. So the y-intercept will occur at 0, 4, and that's going to be right here. And the slope is 4/3. So again, with rise over run, I can go up 4. So I can go up 1, 2, 3, 4, and to the right 1, 2, 3. And the other thing I can do, remember, negative over negative is also positive. So I can do -4 over -3. So I can fall 4. I can fall 1, 2, 3, 4, and go to the left 3. 1, 2, 3. So that's right there. And let me do one more point. Fall 4. 1, 2, 3, 4. To the left 3. 1, 2, 3. Okay. So let me graph this real quick. So one thing I want to draw your attention to, if you look at that point of intersection, you create a 90-degree angle there. Okay, this is a 90-degree angle. And you can really look at any of these and draw that. So this is also a 90-degree angle. This is also a 90-degree angle. And this is also a 90-degree angle. So it's all the way around. Let me make that a little better. So again, if you have two non-vertical lines and you multiply the slopes together, and you get -1 as a result, those two lines are perpendicular. You'll have a situation just like this one. All right, let's take a look at another one. We have x plus 5y equals -10, and we have x minus y equals -5. So again, I'm going to solve each one for y. So I'm going to start out with this one. So we have x plus 5y equals -10. I'm going to subtract x away from each side, and I'll have 5y is equal to -x minus 10. I will divide each side of the equation by 5. Let me scroll down a little bit. So this is going to cancel. And what are we going to have? We're going to have y is equal to, we have -x over 5. Remember, I can write a 1 there. So it's the same as -1/5 times x. And then minus 10 over 5 we can think of as -2, right? Or plus -2. Because 10 over 5 is 2. So then I have my equation in slope-intercept form. So I know the slope is -1/5. The y-intercept will occur at 0, -2. Let me erase all this. So then m is equal to -1/5. And again, the y-intercept will occur at the point 0, -2. All right, for this one, pretty easy to solve for y. We have x minus y equals -5. I just subtract x away from each side, so that's gone. I'll have -y is equal to -x minus 5. I just have a negative out in front of y that's keeping y from being by itself. So I can think of this as -1 times y. So in order to change the sign of that from negative to positive, I can divide by -1 or I can multiply by -1. But I've got to do it to both sides of the equation. So let's multiply both sides of the equation by -1. And so -1 times -1 is 1. So I'd have 1y, or just y. This is equal to -1 times -x is x. And then -1 times -5 is plus 5. So we get y equals x plus 5. So my slope here is going to be 1, right? Because if I just have x by itself, it's got an invisible 1 next to it. So in this particular case, m is equal to 1, and the y-intercept occurs at 0, 5. So what can we say about these two lines here? Are they parallel? Well, the slopes are different. I have a slope here that's negative 1/5. I have a slope here that's 1. That's not the same, so they're not parallel. Are they perpendicular? No, you can tell that right away, because if I multiply negative 1/5 times 1, anything times 1 is just itself. So negative 5 times 1 is just negative 1/5. Right? So these lines are also not going to be perpendicular. So in this case, we would write neither. Right? We're going to say neither. All right, so we want to write the standard form of the equation of the line described. All right, so as you get further into this section on parallel and perpendicular lines, you're going to see a few problems like this, where you're given a point on the line and you're given an equation that it's parallel to or perpendicular to, and you're expected to be able to write the equation of the line. And they'll tell you which form they want it in. They'll say, okay, we want it in slope-intercept form, standard form, whatever they want. Right? So in this case, we want to write the standard form of the equation of the line described. So we're given this information here. It's through the point 4, 5. And it's parallel to this equation here, negative 6x plus 3y equals 15. So remember, if I have a slope and I have a point on the line, I can use my point slope form. Okay? But before we get to that, we don't know what the slope is until we figure out a little information with this equation here. Right? We don't know the slope. Slope equals what? So remember, if two lines are parallel, okay, they have the same slope. So you're meant to look at this type of problem and say, okay, well, if I solve this for y, I can figure out the slope, and then I know my slope and I know my point, so I can use point slope form. So let's start out by just putting this in slope-intercept form. So negative 6x plus 3y equals 15. Add 6x to both sides of the equation. That's gone. 3y equals 6x plus 15. Divide this by 3, divide this by 3, and this by 3. So I get y equals 6 over 3 is 2, so 2x plus 15 over 3 is 5. So y equals 2x plus 5. Remember, in slope-intercept form, y equals mx plus b. M is your slope, so 2 here is the slope. So the slope is 2. Now, this is very important. It trips a lot of students up. If you're a little confused about this topic, you're not doing anything with this equation here. I can line it out once I know what the slope is. I don't need it. It's irrelevant to me. Just get rid of it because it's going to confuse you. You only need it to figure out what the slope is going to be in the equation that you're asked to write. I now know what the slope is because it was parallel to this equation. I took the equation, figured out what the slope was. I don't need it anymore. So I have my slope and I have my point. And again, when we have a slope and a point on the line, we use point slope form. Which is what? It's y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. Okay? Where this y sub 1 and the x sub 1 are the given values from that point. So this is x sub 1, this is y sub 1. And now we just plug in, right? We'd have y minus y sub 1, which is 5, is equal to m, which is 2, right? That's your slope, times the quantity x minus x sub 1. X sub 1 is 4. Now, if they're asking for point slope form, you're done. But they didn't. They actually asked for standard form. So what we're going to do is we're going to solve this for y first. So I'm going to have y minus 5 equals 2 times x is 2x. And then 2 times negative 4 is negative 8. Add 5 to both sides of the equation. I'll get y equals 2x minus 3. Now, this still isn't standard form. Again, this is slope-intercept form. If it's solved for y, this is slope-intercept form. Very important you understand the difference between those. Now, for standard form, again, you want it to look like this. ax plus by equals c. And I know everybody has a different definition for that, but typically in high school, you see it written like this, and you'll say that a has to be greater than or equal to 0. So it's either 0 or some positive value. And then a, b, and c need to be integers, and a and b can't both be 0 at the same time. So in order to make that happen, if I look at this, y equals 2x minus 3, I know I want to move this over here. So I would subtract it away from both sides. So I'd have negative 2x plus y equals negative 3. But according to my definition that I'm using, a has to be greater than or equal to 0. So to kind of clean this up, I just don't want that to be negative. So I can just multiply both sides of the equation by negative 1. Very, very simple fix for that. So if I multiply this side by negative 1 and this side by negative 1, I'll end up with negative 1 times negative 2, that's 2x, and then negative 1 times y would be minus y, and this equals negative 3 times negative 1, which is 3. So I get 2x minus y equals 3. So that would be the equation of the line in standard form that passes through the point 4, 5 and is parallel to negative 6x plus 3y equals 15. All right, we're going to take a look at one more. So this one passes through the point negative 4, negative 3, and it's now perpendicular to 12x plus 3y equals 15. So again, I'm going to solve this for y. So let me start out by just saying, okay, we have 12x plus 3y equals 15. I want to subtract 12x away from each side. That's going to go, and I'll have 3y is equal to negative 12x plus 15. And we're going to divide each side of the equation by 3. And what are we going to have? This will cancel. I have y is equal to negative 12 over 3 is negative 4, then times x, and then plus 15 over 3, that's plus 5. All right, so I'd have y equals negative 4x plus 5. Now, in the last example where we had parallel lines, it was easy because the slopes would just be the same. The slope for this line, as we can see, because it's in slope-intercept form, m is equal to negative 4. Now, with perpendicular lines, it's a little bit more complex, but really it's still kind of easy. Perpendicular lines have a property that says that the product of their slopes will be negative 1. So that means negative 4 times some unknown slope, right, for the line we're trying to get to, is going to be equal to negative 1. So I can use a variable here, right? I can always use a variable when I have something unknown. So let's use z. Now, what I would do is, if I had negative 4 times z equals negative 1, I would divide both sides of the equation, right? You kind of think about it this way, as by negative 4. This would cancel, and z would equal negative 1 over negative 4, which is 1/4. So the slope I'm looking for is 1/4. Because if I take 1/4 and I multiply it by negative 4, this would cancel with this. I'd have 1 times negative 1, which would be negative 1. That's exactly the property that we know from perpendicular lines. So now I know the slope of the line that I'm trying to put in standard form. Again, it's 1/4. So my m is 1/4, and my point on the line is negative 4, negative 3. Now, we are done with this equation here. We don't need it anymore. Line it out. Forget it exists. Okay, you've gotten the information you need from it, and just, again, forget about it. Now, I'm going to use my point slope form. Point slope form. Again, this is my x sub 1. This is my y sub 1. And for point slope form, again, it's y minus y sub 1 equals m times the quantity x minus x sub 1. Now I'm going to plug in a negative 3 right here. I'm going to plug in a negative 4 right here. So I'll have y minus a negative 3, so that's y plus 3, is equal to, and I forgot to say that I'm going to plug in a 1/4 for m, so is equal to 1/4 times this quantity x minus, and we're subtracting away negative 4, so I'm going to put plus 4. All right, so I'm going to solve this for y right now. Again, this is point slope form. If it asked for that, we'd stop there. Solving it for y is pretty easy. We just have y plus 3 is equal to 1/4 times x is just 1/4 x, so you can put x over 4. And then plus 1/4 times 4 is 1. So then I'd subtract 3 away from each side. I'll go ahead and just do this like this. Y equals x over 4 plus, and basically it's going to be negative 2. Right? You can put minus 2. So now I have the equation in slope-intercept form. y equals, and you could write it as x over 4, or you could write 1/4 times x minus 2. It doesn't matter. And I want to put it in standard form. And again, let me kind of cover that definition again. Standard form looks like this. ax plus by equals c. Again, where a, b, and c are integers, a and b are not both 0, and a is greater than or equal to 0. Now, what I want to do, again, I have y equals 1/4 x minus 2. I've kind of got two steps that I need to do. I need to first start by subtracting this away from both sides of the equation. So if I do that, what's going to happen is I'm going to have negative 1/4 x plus y is equal to negative 2. So once I've done that, again, we want a to be greater than or equal to 0. And we also want a, b, and c to be integers. So one of the things I can do is I can multiply by a negative, and that takes care of this being negative, right? It'll make it positive. But another thing I want to do, since I want integers, I want to clear this denominator of 4. So to do that, I would just multiply by 4. And if I'm multiplying by negative 1 and I'm multiplying by 4, I can combine those and just really multiply by negative 4, right? So I would multiply both sides of this equation by negative 4. And so negative 4 times negative 1/4, the negatives would cancel, and 4 over 4 is 1, so I'd basically just have x. And then plus, I have negative 4 times y, that's plus negative 4y, or I can just write minus 4y. And this equals negative 2 times negative 4, which is positive 8. So I have x minus 4y equals 8, and I've fit the definition of standard form. I have ax plus by equals c, where a, which in this case is 1, is greater than or equal to 0. A, b, and c are all integers, so I have a 1, a negative 4, and an 8. That's perfectly fine. And then a and b are not both 0. Neither are 0 in this case, so we're good to go. So we have x minus 4y equals 8, or again, you could say 1x minus 4y equals 8 as our equation in standard form.